Hello, everybody. My name is Markus Sage. I'm the Executive Director of the area, and welcome to the latest area webinar. Really excited to be here with the ViewAR team, and we're going to be talking about digital twins and 3D scans. But for you who have been or attended an area event, a webinar event before, I'm just going to, as per normal, give a quick overview of the area. So next slide, please. Yeah. So the Area Augmented Reality Enterprise Alliance is a global membership-funded not-for-profit alliance. That means we only focus on helping accelerate the adoption of enterprise AR. And we do that by creating and supporting the growth of a comprehensive ecosystem, and we do a number of different activities within that. Next slide, please. The area membership continues to grow. There are 3 different segments of members. There are the enterprises that are deploying AR technology across a whole number of different use cases and solving multiple different problems. We have a bigger group of the providers of technology, including hardware, software, consultancy, platform providers, chipset providers, and then also a number of non-commercial organizations, including government agencies, research institutes, universities, and standards organizations. And by bringing all of the members together, we really kind of learn from each other, develop best practice, and also looking to, as we said, accelerate the adoption of enterprise AR. Next slide, please. That takes me on to what we're actually focusing on, what we call our 4 strategic pillars. So the first one is about delivering thought leadership. We actually call it the Thought Leaders Network now. And that's really about providing the information that business decision makers like yourself on the call need to understand about deploying AR technology. And I break that down into 4 simple pieces of information. You need to understand what problems can be solved. So the use cases. Need to understand or see companies that have actually solved those problems using AR technology, so the case studies, to have an understanding of what technologies are needed, and most importantly, we find about the ROI, the return on investment. How much does this technology cost, but more importantly, how much am I going to make or save by deploying it? Secondly, we focus on networking, about bringing the ecosystem together to learn from each other, to really share those experiences and build those partnerships and insights. It really is a place where the experts in this technology can come and find like-minded experts and work with, learn from, and kind of gain experience and knowledge. The educate side, this is really important. We want to make sure that we're closing what we call the AR skills gap. By working with universities and educational organizations to help them define courses in the technology, but also to offer guest lecturing, outplacement, setting challenges, and everything we can do to really connect the organizations using and deploying AR with the next set of skilled workers. And then finally, it's about barriers to adoption. We know across the ecosystem that there are many companies that have tried the technology, have done pilots, proof of concepts and prototypes, and we applaud that. But what we want is more companies that move into the next successful step of actually fully deploying the technology across their organization, again, potentially for multiple different use cases as well. So we have a number of committees. The committees are focusing on some of the barriers to adoption, so things like safety, security, human factors. We also have a very strong research committee and capability. And if you haven't, please go to the area website and look under the research tab. And there's a whole bunch of information that we've created and research we've created over a number of years now that are very focused on the problems and research that companies actually need. Next slide, please. We've been, because of the kind of pandemic and people not being able to travel, we've actually done a lot of webinars. To be honest, we did webinars before this. So we have a number of different webinars that you can please go and have a look at, again, under the videos, the area of resources and videos tab. We're up to nearly 40 webinars. In fact, with today's webinar, it will be the 40th. There's also podcasts and other kind of pieces of information. And again, you could also go to the area YouTube channel, and there's lots of information there to please peruse and look at. Next slide, please. And then finally, just to say that our final webinar of 2020 has been the year of webinars from the area perspective, but we're working with another one of our excellent area members, Athea, and be looking at their AR maturity model, which is a really interesting piece of work. And that will be on December the 16th, and kind of emails, and it's actually now available on the events page on the area website. So please sign up to that and come along to that webinar as well. Okay, final slide. Okay, so before I hand over to the ViewAR team, just a couple of things. One, we really would like your questions. People that have used this tool before know that there's a questions tab, so please go into that, type any questions, and Markus and Andreas from the ViewAR team will be able to answer those at the end. If we're not able to answer all of the questions, then they'll follow up afterwards with a kind of written response. And then after the event, the ViewAR team will be sending the kind of link to the YouTube channel and kind of presentation and stuff like that. So you'll be able to follow up and share with your kind of team and the rest of the organization as well. So my last thing is to hand over to Andreas and Markus from the ViewAR team, and I'm really excited to listen to these great experts on digital twins in 3D scanning. Guys, over to you.
Thanks for the introduction, Mark. Hi everyone, my name is Markus Meixner. I'm the founder and CEO at ViewAR, and welcome you all to our webinar that will talk about digital twins and 3D scans and how they are key to AR applications. We will basically talk about 3D scan creation, as in how to create digital twins and which scanners you can use and basically how this works, and then talk about hardware-free indoor navigation, as this location awareness is key to AR applications in industrial facilities and so on. And then we will talk about AR step-by-step instructions and capabilities of remote assistance and IoT data visualization. And then we'll have a question and answers section. I'm now handing over to Andreas.
Yeah, thanks, Markus. Thanks, Mark. Hello, everyone. So I'm gonna do the theoretical part here, and Markus will then take over again, explaining what we can do with this. I'm gonna start out with digital twins and 3D scans in general, as those are basically the foundation that we build our applications on. And of course, I mean, there is several types of digital twins existing. A digital twin in general is a replica of a living or non-physical entity. That's the general definition. In our use case, or in our cases, we basically talk about scanned spaces, scanned and digitalized environments. So what use cases can be achieved with a digital twin? Of course, it's always meant to provide access to an area where physical access is not possible at the moment. So with COVID or for other reasons, travel restrictions, etc. So people on the one hand can be trained in a scan because they get acquainted with a location before they actually go there. They can be trained on hazards and other important features of a location. Of course, a digital twin can also be used for insurance cases, as those scans can speed up insurance payment cycles, as the evaluation of damages is supported and speeded up. But it's also frequently used for construction sites, where basically you compare what is built with what has been planned, and you can compare the construction in its final stage to what is like with an A/B testing. Yeah. So we use different scanning systems to digitalize a space. On the one hand, Matterport, but also industrial scanning solutions like Navis, and also other scanning formats can be imported, where we can, of course, provide more detail in another session. Those systems in general, they do basically differentiate themselves, because I mean, Matterport is mostly built for smaller locations, originally focusing on real estate, but also capable of scanning larger spaces until a certain limit. But on the other hand, we have Navi scanners, which are trolleys that can actually cover large areas very quickly, and of course are correspondingly much more expensive. So both systems have basically their pros and cons. Matterport is the market leader for digitalizing spaces in the real estate sector. They're rather cheap compared to other systems, and they also come with an admin interface and of course the hosting of the scan. A Navi scanner will be much more expensive to procure, but the good thing is that basically you can find a service provider nearly everywhere that can digitize a space. I mean, you see it on the slide. We have a rule of thumb when we're talking about how long it takes to make a digital twin. Usually we calculate around an hour for 1,000 square meters with a Matterport scanner, and 3,000 to 4,000 square meters can be covered with a Navi scanner within an hour. Can even be quickened up depending on the operator. So this can be the result of such a scanning procedure. Here we see basically one of Vienna's largest museums. It's over 20,000 square meter that we have captured here. And basically this is the final output of the scanning. And you see that basically the whole venue has been covered, and also the stairways and complex areas within it. So moving on. What we create with the scan is a so-called point cloud, and with those point clouds we can generate and then calculate a visual recognition pattern, which allows us to position ourselves in a space and therefore understand where we are and where information has to be displayed accordingly. The system itself compares the camera image with the panorama images taken during the process to distinguish between unknown and known geometry and to identify the user's position. And this allows for very accurate positioning within and spatial understanding within a location. So with that, we also get a map created, and the map is basically an ideal interface to administer the information that is visible later on in AR. You can, on the one hand, assign points of interest easily to those maps. You can edit them, delete them, assign various formats of information, as in documents, videos, links, whatever you want to have there. You can also input text that can be later on reproduced by giving text to speech. And you can, of course, also define service routes, which is very important when we're talking about service processes and maintenance processes. In this example, it can be an assembly hall. In other examples, it can be like a hotel or some other large venue where you basically assign information, expiry dates of fire extinguishers, and other information to certain coordinates, and then later on can retrieve this easily. Most importantly is that we have combined our platform with those interfaces so that we can automatically import that information into our system. But of course, there is also the one thing is administrating this on a desktop. The other thing is when I'm actually at the site. So of course, we also wanted to take care to offer a possibility to easily integrate new points of interest, new informational points on the location, when at the location, and this is done via OCR scanning or manual placement, which is a feature offered in the app. So you position yourselves within the space, and you can then by link information to a coordinate by just using the app itself. This can, of course, either be done by scanning the coordinate or by just adding it via manual placement. Of course, this can also be useful when it comes to production data or other relevant data, as users can then access the information right on the correct spot. So on the one hand, we now have a scan, we have a pattern and a map with linked information, but now we have to use this productively. And for this, we have to know as a user when we're actually at the location where we are. And historically, positioning systems have been various and always limited to hardware installations. And this is something that we have been working hard on to overcome. And before I finish with this, I want to give a brief overview on the different positioning systems. Of course, most of you will be acquainted with the beacon systems, which do work with a beacon SDK. So there you will install beacons within in the location. You get a limited accuracy, which is defined by measuring the different beacon signals, but there the accuracy will be between 5 and 8 meters. And of course, installing and maintaining those systems is also always connected to cost. The other system which offers higher accuracy would be ultra wideband antennas, which can be installed. We're integrated with the Coupa system. They're super exact. Of course, they're also not cheap, as in their original definition was or is a real-time asset location system. So they're mostly used for manufacturing processes and not actually for providing indoor navigation. QR code systems are known as well. Based on the QR code itself, they are rather cheap to install, but of course you would have to put QR codes everywhere in your location. And finally, the latest approach that we want to present today is the visual approach based on the visual recognition pattern. And there we actually can get the accuracy further down even, and creating such a pattern based on a scan is compared to other systems also more economically is achievable. So without any hardware, you want to navigate a space. This only works when you're able to, from the camera image, distinguish or determine where you are. And this works as with that so-called recognition pattern. The good thing about this pattern is that it's downloadable, so we don't have any need for Wi-Fi. We can work in buildings where Wi-Fi is like a problematic factor. In a hotel lobby, you will have a different network than on the 7th floor. Also in hospitals, you won't have network connection everywhere. And therefore, this possibility to actually pre-package this pattern onto the app is quite beneficial. And like from our experience, the system initializes within 0.5 to 1.5 seconds, so it's very quick and also user-friendly when it comes to the positioning itself. I'm gonna now hand over to Markus, and before Markus explains you what like all the features we can add to this, we're gonna show you a quick video just to give you a brief overview of what can be achieved with this.
So basically, this video will give you a quick overview of how this looks using our system and yeah, visualizing the actual feature set of our industrial AR suite. So as previously explained, you start with scanning your location. You can yeah, do that with various types of scanning data. Once you have that digital twin, you have a 3D model for admin interfaces with where you can mark those points of interest and where you can basically apply your business logic to. In terms of adding those points of interest, you can add them using our OCR feature, for example. So besides manual adding, we support the filming of actual physical labels and then record the coordinates of such labels. So with this, you can record hundreds of items in an hour. And then you actually have AR indoor navigation. You film around, the system localizes, and then you see a navigation path here visualized with a dotted line, and you can follow that line to your actual destination, and it will recalibrate on the way and display it accordingly. So once you have reached your destination, step-by-step instructions come in handy. Here you see that there is an instruction placed to fill in paper on the printer, and it visualizes the process and where you would have to do what. AR remote assistance is obviously also a feature that comes in handy, as in transferring a live camera image seen on the left, a second person seen on the right, and you can synchronize touches and show annotations and basically support a person remotely. Going through those features separately, basically you can locate items and navigate to items. It's not just about finding single items, you can also define routes and basically optimize processes in those regards. Step-by-step instructions, as you have seen in the video, let you on the one hand show a process or define a process of steps, as in text hints and text instructions with points that are highlighted. So the data input to this is which coordinates should be highlighted and which text should be shown as general instructions and which instructions should be shown on the actual point. So you could say, open this cover, press this button, walk around here, and do this and that. So those are location related instructions. Remote assistance, I guess that most of the attendees are aware of such features. So on the one hand, you can stream a live camera image and synchronize touches and annotations. This, of course, speeds up the communication. Like instead of verbally talking about which button to press, you can actually draw on the button and the remote person sees it accordingly. IoT data visualization is obviously also a hot topic. So you can basically display IoT data on the actual spot. This example that you see here is done using object recognition, so 3D CAD recognition of models. But you can also do this just by placing IoT data with coordinates. And here you can see that once you unplug the pipe, the sensors alert that the value goes down. And this is reported by a Beckhoff unit, and basically providing an IoT API. In terms of the integration, this is most of the times a very hot topic when clients ask us, how can you integrate this? And we have come up with an approach that is quite easy to handle. So we've come up with an approach called deep links. You can basically create links that trigger a navigation to a destination, or that trigger step-by-step instructions or a remote assistance call, or display IoT data. And such links you can run on iOS, Android, and even in the browser. So in the browser, you would have 3D views and VR modes. And as a brief example of how such a configuration for a work task would look like, we've put a few JSON data structures on the right side. So you will see, if I quickly go through the indoor navigation example, you will see it consists of a version number, an action, which is navigation, and then a user profile information, and it has a location config containing a location ID. So this will load the according twin and the according 3D model and the visual recognition pattern. And you can define a list of navigation points the user should be guided through, and on which points you should see which labels. So in this case, you would navigate to production line 11, and on a production line 11, you would see a label with production line 11 and replace item as an additional text. Same approach, you can initiate a remote assistance call as a sender or a remote assistance call as a receiver, where it's basically about in which room do you send them and which call ID do you give them. And basically all you need to do is this string gets converted to a base 64 string and appended to a web URL or appended to an app link. And you can take those two links and put them into an email, into a WhatsApp message, into whatever automation you have behind that. So if you're talking about a ticketing system, you could add a link of finding that specific item, or even steps to accomplish for a specific item. So if predicted maintenance will tell you you need to fill in oil on this engine, then it could send out a link that would contain a navigation and a step-by-step instruction to this engine for the oil replacement process. And this is an extremely powerful approach because you could basically scan a venue next week and do an integration of such a data on your side in your IT system, and and you would be ready to go right away. Yeah, so I think this is a quite quick way forward. In terms of the company history, a few facts. So we were founded in 2011. We're headquartered in Vienna. We're a team of 18 people, and we were also selected by SAP with their acceleration program, and which also makes us very proud, being one of 7 companies in a batch of 700 applications. To give you a bit of an overview of basically the fields we're working in and the technologies we're working with. So actually we have our roots in the field of product visualization. So here you see a parametric application that stretches an awning and visualizes shade according to compass and GPS. We're also quite active in the furniture industry, as in visualizing items and placing them in the environment. But also indoor navigation is a big focus area of ours. So be it in the field of consumers, like for museums or airports or retail scenarios, or industrial applications. Remote assistance is also a hot topic for us. So not only to have remote assistance and do annotations, we also support an approach that lets you save a visual fingerprint of an item and then save those annotations, creating kind of a knowledge base. So once somebody else needs to see those advices, he can load this fingerprint and see it in place, being independent and not having somebody else on the call. Object tracking is obviously a focus area of ours, so we can detect physical items in the camera image and overlay them with augmentations. So this can be used for instruction purposes or quality end-of-line checks. You can also overlay physical items with different variants and so on. Industry 4.0 is obviously a focus of ours since quite long. For Lufthansa, we created an application for cargo volume scanning using depth cameras. All sorts of applications that basically shaped the ViewAR system and that added features to our SDK. As a brief introduction on our system and how it's structured, we have a ViewAR core that is responsible for rendering and tracking and the resource handling, and we overlay that with an HTML layer for the UI. Our UI is actually programmed with frameworks like React and Angular, which makes it much more efficient and quicker than programming in systems like Unity. And then it's connected to a cloud, which can also be on-premise, that is hosting the 3D content and the actual application UI logic. And then we have our developer portal, which lets you administrate the actual applications and its content. So as a brief overview of clients that we've worked with and that we're working with, they're from all kinds of industries and all kinds of sectors. Meanwhile, we're more and more switching towards the industrial field and focusing on that area. Yeah, now it would be time for questions, and let us know how we can help you with your use cases.
Fantastic, Markus and Andreas. Thank you very much indeed. We have a few questions. I'm kind of really intrigued in something I see being really beneficial.
Mark?
I can't hear Mark anymore.
For point cloud, delivering apps in almost no time at all. Can you give some kind of real life examples of how that's actually working out?
I'm sorry, Mark, you were cutting out. Did you ask how long it takes to do such scans, or?
Yes, my apologies. Yes, how long? And also, how long does it take to build the apps that you can, from the integration part?
Basically, we have a so-called template system in place. So we create templates for certain use cases and certain verticals that you can then customize to your needs. There are 2 complexity levels you can approach this. So on the one hand, you can use our developer portal to basically assemble an application and configure an application quite quickly with the available feature set. But you could also get source code access to those templates to customize them to your needs. In terms of testing environment, it might be relevant that we have a so-called experience app, which is an application that can transform into whatever you're currently creating and whatever you're currently testing. So we're completely eliminating development environments. So basically, a guy in Austria can program an application and another guy in Finland can run the SDK app, enter an app ID, and run this experience. So that's pretty straightforward. In terms of time after doing a scan, you could see first results after a few days, actually.
Excellent, thank you. Maybe a little bit more in-depth question here, if you can still hear me. I'll read it out, but you should also be able to see it on the questions part. Once you have built a 3D model from the scanned point cloud, what are you using to perform relocalization on the device? The model you created, the original point cloud, or a sparse representation of that point cloud? A bit detailed, but I think an interesting bit of insight you can provide.
So obviously not everything's, let's say, public information, or there you're touching a bit of a sensitive point, but I can tell you that, yeah, there is basically the point cloud, and the 3D model is reduced to a sparse feature point cloud. And so visual recognition in combination with edge tracking is used to determine the position. And yeah, so it's basically visual recognition.
Okay, great. Let's have a look at one of the other questions here. Let's just take a simple one. How does this perform for outdoors compared to indoors?
That's a good question. So currently we're purely focusing on the indoor scenario in terms of the visual recognition. But we have a system in place called Tracking Fusion System, which actually lets us combine and utilize all sorts of tracking inputs. So as Andreas previously mentioned, we can use systems like Bluetooth beacons or even GPS coordinates to establish a permanent AR coordinate system. So for outdoor scenarios, we would currently go with using GPS coordinates. Basically, to give you a bit of insights there, we're collecting multiple GPS measurements and combining that with the movement curve of the tracking system, the local tracking device, the local tracking curve, basically. And by that, we can make GPS results like almost 10 times as accurate. Yeah, so that's what we would recommend for outdoors. But we're also looking into some point cloud and recognition algorithms and approaches that can handle outdoors. It's a bit tricky because of sunlight and different seasons and so on.
Okay, great, thank you. Just looking through some of the other questions as well. I think some of them are perhaps a little bit detailed to ask in this forum, and we would definitely follow up with them. Just wondered about how do you optimize the 3D model data size when viewing in AR and share remotely whilst maintaining real-time visualization? Is that something you can touch on, or is there a secret source within that answer?
Obviously, there is a reduction of the 3D geometry, but I have to say the question is, do we actually need the 3D geometry for AR? The only two reasons you would need this for is for occlusion effects. So you don't want to, let's say, look through walls. You want to basically occlude your navigation paths and so on. But this could also be eliminated by, for example, just visualizing the next 4 meters or 10 steps of walking. So then you would potentially not need occlusion. The second reason for handling the 3D model in AR would be to interpret touches and user interaction, which could also be determined by using some live tracking input and features you would get from the camera feed. But for the VR scenarios, as in running this in the browser and either opening a step-by-step instruction with a virtual walkthrough in the browser or a 3D perspective view, obviously we need to do some polygon reductions there. Yeah, so we have systems in place for that as well.
Okay, another question. What hardware not hardware in means of devices are supported? Not quite sure I quite understand that question, but
maybe this means in terms of what hardware devices you would need to run this. So basically we're recommending to use on iOS at least iPhone 7 as a start, and on Android as Samsung S8. Just to give you some hardware criteria, we don't need a depth camera, we don't need the super newest devices, so that's fairly easy.
Okay, great. I guess, Markus, Andreas, you want to have a look at the other kind of questions and see if there's anything there you would like to answer. I think there's a few very detailed ones, which I'm sure you'd be happy to follow up individually afterwards. Okay. I think there was a follow-on question to the last one about how about HMD devices?
So we're currently working on the support for the HoloLens, and we're also looking into devices like Nreal. As you might have heard, Nreal are AR glasses that are around $400 as a unit, and they connect to your smartphone. And they almost have the same feature set of HoloLens, but extremely lightweight and very cost effective and size effective. You can really like put them into your jacket as if they were sunglasses. So we're seeing a lot of potential there. So those would be the two devices we would be currently looking in.
Perfect. Okay, so I'm just going to end up with one last question, if that's okay, and just get you to kind of just summarize the USP, the unique selling points of the ViewAR platform.
Definitely, yeah. Yeah, basically, I mean, besides the 10 years of experience in the field, I think it's key that you can combine those multiple modules into one application. Because if you compare this to the opposite, as in having 5 different applications and 5 different AR systems you would need for 5 different AR application types, that would obviously be a bad infrastructure and will cause some integration topics. And I think we're offering an extremely unique feature set with what we cover and the approach how you can customize it with source code access, with the development environment, with the multi-platform approach of iOS, Android, and the web versions for admin interfaces. That, yeah, we bring quite a few arguments to the table in terms of USP, and yeah.
Perfect. Well, I think Markus, Andreas, and everybody listening, I think that would be a good place to end. As I said, there are some questions that the team will follow up with, which are a little bit more detailed in nature. But I want to thank the ViewAR guys for an excellent presentation and some really great insights. And I'm very much we see great solutions using one sort of kind of technology, but being able to deliver and solve some real business problems. And I think we've seen a real insight into that today. So I wish everybody the very best and hope that you're all well and safe, and remind you that there's another webinar on the 16th of December. And thank you finally to the ViewAR guys, and speak to you all again very soon.
Thanks, Mark.
Thanks, everybody. Thank you.
Have a good day.